Greetings, my little triglets. Welcome to section 4.5. We're still going to continue talking about logarithms and exponential functions, but we're going to get a little more real life. Exponential growth and decay is a very big aspect of this topic. So, our growth function. Now you've seen this before. Some of the letters might be a tiny bit different. A and then A sub 0 E K T. In the past, you might have used P and then R was the K, so the PERT formula. This is just a little bit different. Growth is when K is larger than 0, so that's how you know it's a growth formula. Okay, we'll write that next to it. And if K is less than 0, then we know it's a decay problem. All right, let's write down what everything is. A sub 0 is the original amount, and that's when time is 0. So in the past, you used this formula in money, so it was more like principal amount of money, but this might be some other ingredient that's the amount. So A is the final amount at time t, and K is the constant growth rate. Okay, so we're not necessarily talking about money. Okay, and decay is the exact same formula except the K ends up being less than 0. All right, let's talk about the time here. Time, in this problem, we're going to talk about population, and the time is the number of years after 1970. Whoops. So that means t equals 0, time equals 0 at the 1970 year. And the population in 1970, the U.S. population was 203.3 million. Then in 2010, not too many years ago, the population was 308.7 million. So yes, we have gone up a little bit. All right, so our job is to find out what will it be, or when will it be 335 million. Okay, so that's the question of the day. So what we need to do is use that formula and figure out the K, and then replug that back in and use our 335 million number. So let's start out with what we know. So the final year is 308.7 million. It was 203.3 million at the beginning, and we have an E, and we have a K, and then our T. Well, how many years is it from 1970 to 2010? Looks like it's 40 years. So we put that in for our T. Now, the way to solve this, because we have an E, is we are going to be using the natural log. But I first have to isolate the E part. So I'm going to divide both sides by 203.3. All right, when I do that, I get, well, I'm not going to work it out quite yet. I'm just going to keep writing it. But the next step here, so this is gone. The next step is to take the natural log of both sides. So I'm going to take natural log of 308.7 over 203.3 equals the natural log of E, K to the 40. Now the reason I took natural log is because I have an E. Don't forget that the base of natural log is E. So if I have these the same, then it's just K times 40 on the right. The natural log of all of this, we are going to divide both sides by 40. Okay, so then I just do all this on my calculator, and then I have it worked out to k is approximately 0.01. Now, what we do with that is we put it back in the equation and put in everything but what we're missing. So let's say 335 is the final amount we're looking at. The original amount was 203.3. E to the k now we know is 0.01, and t is what we're trying to figure out. We're figuring out what year, how much time. So we have to solve this pretty much the same way. We're going to divide both sides by 203.3. Then we're going to take the natural log of both sides. I'll put it here. Natural log of e, base e, then would be 0.01 t equal to the natural log of 335 over 203. And then I want to divide both sides by 0.01. And when I do that, I get t equals approximately 50 years. Now that's 50 years after 1970. So add 50 to 70, and you get 2000, the year 2020. So the year 2020, we should have a population of 335 million people. And it's just going to keep growing unless we have some catastrophic plague that hits all of us. Let's hope that doesn't happen. All right, let's do one with decay. All right, decay. We're going to do a carbon dating problem. I didn't know carbons went out on dates, but we'll talk about that like it's a serious topic. Let's talk about the Dead Sea Scrolls. The Dead Sea Scrolls, it's 5,715 years for the amount of carbon-14 to decay to half the original amount. Okay, so that's its half-life, 5,715 years. So I want to estimate the age of the scrolls that have 76% of the original carbon-14. And it was found in 1947. All right, so let's take a second here and figure out what's going on. So I am going to use that formula again, A equals A sub 0 E k to the t. And this time k is less than 0. The time is 5,715 years for it to be half of the original. So you got to think about that. The amount, the final amount, is half the original amount. So that means A is 1/2 A of the original. So instead of A in this formula, we're going to put 1/2 A sub 0, meaning half of the original. So let's do that first. So 1/2 A of the original is A of the original E, K, and then the amount of years, 5715. All right, so then I see A sub 0 on both sides, so I'm going to divide that out. Whatever that was, I don't really even have to know that. I'm left with 1/2 equals E to the K 5715. Just like in the other one, we're going to take natural log of both sides. And what happens there is natural log of 1/2. This natural log of E is just 1. We put it equal to 5715k. Then we divide to get k alone, 5715, and we get k to be approximately negative 0.000121. All right, so all we did in that whole process was figure out what k is. Now we have to go back and answer the actual question. So 70%, 76% of the original is what we have for our final amount. So I need to use that 0.76 of the original. So that's our A is equal to A sub 0 e to the negative 0.000121 t. Okay, so now, just like we did before, we're going to divide by A sub 0 to get that out of there. 0.76 equals negative 0.000121 t, because, well, I didn't write it, but I'm already taking the natural log of that, so I'll put that in here. All right, so now I'm going to divide by negative 0.000121, negative 0.000121, and I get t equal to 2268 years old. So those Dead Sea Scrolls. Now that, you have to add the number of years between 1947 and now to get the actual age. So this was the age in 1947. Okay, if you want to find its actual age, just add the years between then and now. All right, so that's kind of the process you're going to use. You're going to throw things into the formula, then take the natural log, then throw it back into the formula with k, and take the natural log of both sides again. All righty, that's it for now. Trig love is all over. All you have to do is look for it. Ta-ta for now.